Section 2.5 linear regression. Let's go through this worksheet. So it describes what is meant by a scatter diagram. So that's when we plot data on an XY graph. Or plot points, where it's not, again, it's not the exact correlation. That's the relationship between two variables. So it could be either positive or negative, or no correlation. Positive correlation, so that means as x increases, y increases. So as x increases, y increases. That's a positive correlation. A negative would be x increases and y decreases. I guess I could also say as x decreases, whatever. We'll move on. Match each scatter diagram with the correlation of R. So here's the thing about R. Like this guy right here is like a perfect R, and it's positive, so that should be 1. Right, so like that's perfect. This looks good, and those are like good, but a straight line is perfect. So this one right here is A. So that's done. Likewise, see how that's perfect? That's like almost like a straight line. So that's gonna be over here, E. This one right here has no correlation at all. It's all over the place. I can see a line anywhere. So that's C, or equals 0. Now this one's a positive correlation, but not perfect. So it would be B, it's positive. And then this one's a little more contained, but still not perfect. So that's D, but and it's negative. So there we go. So it wants to give provide real world quantities that represent each of the following. So a positive correlation. So say it's a positive, this could be anything, positive correlation. So X goes up, Y goes up. Temperature and ice cream sales. Beach visits, probably better. I'm gonna do that. Right, so the temperature goes up, and beach visits go up. A negative correlation, so something goes up, what goes down? I'm gonna say with temperature gets easy. So as it gets hotter, what happens less? It gets a lot less. Sweaters. And then we're gonna do no correlation. So it's two things don't correlate. How about beach visits? And GPA? I imagine those things don't correlate. The number of times you go to the beach doesn't really matter what your GPA is. So things that no correlation, right? Like people who have high GPA go to the beach all the time. Like people who have low GPA and go to the beach all the time. Okay, next one. The table at the right shows the relationship between the number of students in a math class and the average grade for each class. Make a scatter plot, find a regression equation for the data, then graph the regression line. So we need a calculator for this. So I have one over here. Right, so we need TI-84. I guess if you don't have a calculator, you use Desmos. So you can also do this on Desmos. So we want to make a scatter plot. So let's type in the data. So we're going to stat, then we're going to hit edit. That's going to type it all in. And boom. I did it off camera, so you don't have to waste time seeing me type it all in there. But it's all typed in now. Feel free to pause if needed. So they want me to make a scatter plot. So if you hit graph, start with bad, right? You can't say anything because the window's not correct. So you can fix one of yourself if you want by going to window and then typing the X-min, which would be around, I'll probably put 10 to give myself a little window here. So that's my lowest. My X max is 32, probably put 35, just give myself a little buffer. My Y min is around 7, let's go 75. And my Y max, let's say 85, just a little buffer. So you get something like this. So now, I forgot to turn on my stat plot. So let's do that second stat plot and then turn it on. See how it says plot off? Turn it on first. That is a scatter plot. We're good there. L1, L2, we're all good. Now we can hit graph, and now you can see the data. Right, it's all right there. That's one way to do it. Other way to do it is with the calculator for you. If you hit zoom, there's a stat button toward the bottom. I think this is a 9. So you just press 9. And it'll do the window for itself. It'll use your data to figure out the window itself. So we get this. Find a regression equation for data. So we'll do that with the quit. Let's go to stat, calculate, linear regression number 4, L1, L2, frequency list, we don't have a frequency list in this case, so we're going to leave that blank. Right, it's just class average. Store request, that's if you want to save it. So if you want to type this in for L1, so graph it, or Y1. So you don't have to, you can leave that blank if you want to, but if you want to say, if you want to graph it, all you do is this, press Y1 there. Easiest way to do that is press alpha F4, and then Y1 pops up. If your calculator is updated, then you hit calculate. So there's my linear regression. So Y equals negative 0.21, we'll do nearest hundredth, X plus 85. Right, so just type those values in. That's my linear regression line. I probably should have made a scatter plot. It looks something like this. Doesn't be perfect. Right, just get the idea across. And if you hit graph, there's your linear regression. Mine does not. That's not a very good representation of that, but that's the idea. What's the correlation coefficient of the data? The correlation coefficient is the R. So now all calculators have this. You have to have at least TI-84. So I generally don't add this. I don't ask this on a quiz or test because you have to have a TI-84 at least to find this. But the way you do that is, let's see. When I went to mine, I don't think I had it on yet. So normally there'll be an R right there. So the way you turn that on is you go to mode. Toward the bottom, there should be a stat diagnostic. Turn that on. And now when you do the same thing we did earlier, where we hit the linear regression, it'll give you the R, which in this case is negative 0.7. So it's a strong negative correlation. That's right. What does that mean is, as the class size gets bigger, the GPA drops. Describe the correlation. How accurate is the regression equation? So again, if I want to describe the correlation, it's a strong negative. How accurate is it? I mean, we can't tell how accurate the data is. Looking at the graph, it's fairly accurate. I mean, it's strong correlation, right? It's not going to be perfect, but that's the general idea. Let's do another one. Each day a factory records the number of boxes it produces and the total production cost in dollars. The result of 9 days is shown below. So this is 9 days of producing boxes and production costs. Write down the equation of regression line. So we got to find linear regression again. So we got to use our calculator once again, and put the new data in. So I'm gonna go to stat, go to edit. Now I have data in here already, so I'm gonna get rid of that data. Move this over. So I'm gonna go to L1, and now here I'm gonna put clear. If I hit clear and then enter, it clears it all up. If you hit delete on accident, well then it just deletes the column. So to get it back though, it's not that bad. It's actually super easy. You just hit stat. Well, let's get it here first. Second quit. Okay, we hit stat and then you go to setup editor. That's all you have to do. So if you ever accidentally delete a column, you just do that. Hit enter. It says done. You go back to stat edit, and it's all back there. So that's an easy way to fix your if you accidentally delete. So just put setup editor. And then we can clear this instead of deleting it. Now it's all clear. Now I can put the new data in, which I do off camera. So there we go. I typed it all in. Hopefully that's correct. I think it's all good. Anyway, write down the regression equation. So I'm going to do the same thing we did before. You go to a stat, calculator, linear regression, number 4. And then L1, L2, yep. Frequency list, again, there's no frequency list in this case. Store request, I'm not making a graph, I don't see anywhere, so I don't really need this request. And then calculate. So here we go. So my regression equation will be y equals 10.66 x plus 120.79. If I did nearest 100, if you also do nearest 10, it's fine. So that's my regression equation. Now let's go to the next part. Interpret the meaning of the gradient. So that's fancy. I'll just put slope if I ever ask you that. That's what gradient means slope. So what does the slope mean here? So here's the thing about interpreting the meaning of slope. This is my slope, right? So slope is 10.6. Remember, slope is y over x, right? It's rise over run. So I don't have an x on the bottom here. So my x here should be 1. Make it a fraction. So what does this mean? Well, what is 10.6? It's the y value. What's the y value? Production costs. And then what's the bottom? Bottom is the x. What's the x mean? Boxes. And the key here is the divide line is just a fancy way of saying per. So this means it costs 10.6 boxes, $10.6, sorry, per box. So that's what the slope means here. It's on average, it's costing $10.6 per box. And that's, I just got that from the slope, right? Slope is y over x. So here's my slope. Here's my slope. So y over x. And then what does y mean? Production cost per. What does x mean? Boxes. The y-intercept. So the y-intercept is when x is 0. So my y-intercept is this guy. So kind of the same idea, right? That's my y-intercept. That's $120 to make 0 boxes. Or if you want to know a way to say it, it's that the initial cost is $120, like to start this up. I guess I'm rounding to $120. So either way is fine. Estimate the cost of producing 60 boxes. So boxes is x. So all we're going to do is sub 60 in for the equation right there. So I get my calculator out. Now put 10.66 times 60 plus 120.79. And I get 760.39. So that's the cost of producing 60 boxes. One more, and then we're done. Table that shows the amount of time collected, time a collection of families spent preparing homemade meals each week. The amount of money they spend each week on fast food. So time on homemade meals. So like they spent 3.3 hours on homemade meals. They spent this family spent 3.3 hours on homemade meals, and they spent $85 on fast food. This other family spent 6 hours on homemade meals, and they spent no money on fast food. So like it different, right? This one spent $2.5 hours on homemade meals and $100 on fast food. So that's all that table means. Draw a scatter plot. So we got to type our information in again. So stat edit. Let's clear these. Again, we're not going to delete, we're going to clear. And then we'll type in all our data in. So it's all typed in again. Let's draw a scatter plot. So I think my scatter plot should still be on. Yes, it is. If it graph, you won't. I gotta get rid of that line I had before. That's the regression equation for the one we did earlier. So you won't see anything because my window's off. So I'm gonna fix the easy way now. Let's put zoom then number 9 because that's stat data. And there you go. Right, you can see the family that spent no time, no money on fast food, and then all the rest. So that's my scatter plot. Calculate. It looks like it's a negative. I probably should draw it. Right, that's the question. So I was doing this. It looks kind of like this. Again, it's just a sketch. It doesn't be perfect. So we get an idea what it looks like. There we go. Calculate the value of r. So the only way to do that is to find the actual linear regression. So we're going to go stat, calculate, number 4 is linear regression, blah, blah, blah. I will still request it. I'm probably going to look back at that graph. So I'm going to put alpha at 4 so I could store it, my new equation in there. And hit calculator. There we go. My r is negative 0.87 if I go nearest hundredth. So that's a very strong negative correlation, which just means the more you spend on homemade meals, the less you spent on fast food. The more time you spend on homemade meals, the less time you spend on fast food. We have a negative correlation. Finding the equation of the least squared regression line. That's this linear regression line. So we found it right now. So y equals negative 12.65x plus 116.16. I'm rounding to hundreds everywhere. Interpret the gradient and the y-intercept of the least squared regression line. So that's the question we just had already. So for slope, so again, look here at my slope, negative 12.65, and put that over 1, and that's y over x. So what's y? Money on fast food. And then what's x? Hours homemade meals. So it looks like you save $12.65 for every 1 hour homemade meals, right? So it's negative $12.65 money for fast food for every hour you spend on homemade meals, type of thing. So you're gonna save about $12, $13 on $13 saved per 1 hour of homemade meals. So that's going on there. The y-intercept, where all the y-intercept is the initial whatever. What's the y value here? Or like the best way to think about y-intercept, I think, is think about it as x is 0, and then what's y? In our case, y is 116. So what does that mean? If I spend no time cooking homemade meals, I'm gonna spend about $116 on food. 0 hours home cooked. So you spend about 116 on fast food. So that's D with D. Another family spends 5 hours per week preparing homemade meals. Estimate how much money they spend on fast food each week. So they're spending 5 hours, X is hours, right? Yes. So we're going to sub in 5 there. So this is your calculator. I'm going to show you, so we type it all in. I'll do that right now. So negative 12.65 times 5 plus 116.16. And I get about $52. So that's one way to do it. Another way to do that is if we look back at our graph, we have a line now. And since 5 is in here, I can look at where 5 is. 1, 2, 3, 4, 5. And look, see where it hits the graph. Now it's hard to tell right here. I don't have markings, but you could do this. If you go to, where's it at? Calculate. Second, calculate. And it says value. So it wants to know what X value you want. I want the value of 5, because that was a question. And I get 52.88. So it's very similar, right? Because I rounded here, so that's why it's not exactly the same. But 2 ways to do it. Anyway, that's the video.